Okay, so we're going to wrap up our discussion of similarity and congruence by moving on to similarity. And we'll look at this first problem here. On your handout it says consult your congruence and similarity handout. What major modifications need to be made is you investigate whether two triangles are similar versus if you were investigating if they were congruent. What sets of conditions are just enough to prove two triangles are similar? Well, here are the major modifications. Corresponding angles of similar triangles are 100% congruent, because remember, congruent triangles are what we call dilations of one another. One is a bigger version of the other, which means that the angle measures all hold, but the side lengths are different. But here's the relationship that exists between the side lengths. They are proportional. So if this were triangle A, B, C, and this one is D, E, F, we know that side AB written over side DE should have the same value as BC written over EF, and that should have the same value as AC written over DF. These are all corresponding sides for the smaller and bigger triangles respectively, and they should all simplify to the same exact fraction. So they are what we call proportional. So side lengths are proportional, and angles are congruent. What are the different ways or sets of conditions that need to exist to prove that triangles are similar? Consult that handout that I gave you last time. By looking at that, you realize that if two angle measures are equal, that automatically implies the third one is equal. That is enough to prove that they're similar. If your three sides are proportional to one another, so they're not equal, remember you have side, side, side for triangle or triangle congruence, and that means that all sides are equal, but then you have side, 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 meaning that they're proportional to prove triangle similarity. And then you have side, angle, side. Now that means these two sides of the respective triangles are proportional and the included angle is equal. But those conditions, if they exist, are enough to prove that triangles are similar. Let's apply this, not in proof, but actually in some problems. I want you to determine whether the following sets of triangles are similar. If they are, state how you know and finish the similarity statement. So we're practicing with these similarity statements, writing the vertices in the correct order so that corresponding parts match up. Now you see that each of these has an angle measure of 61 degrees. Are there any other angles or sides that have a specific relationship? Indeed, there are. This vertical angle is equal to this vertical angle. And so by angle, angle, we can say that these two triangles are congruent. We have to write them in the correct way. So we are given HGF. You know that H is going to correspond to itself. That is going to be similar. We use a single squiggly line. That's similar to triangle. H. G corresponds to T. So H, T, and then S would correspond to F. So that would be our similarity statement. Let's look at this second one. Now this second one, we're only given side lengths, so we're going to have to check for proportionality. We're given the lengths of the two sides of our small triangle KBC, and we're given the longer side lengths of KLM. So we would have to write a proportion between corresponding sides for KB to KL, so that would be 16 over 88. And then we would want to write the other one is 25 over what? Well, we would have to add those together. So that would be 25 over 132. And then you would want to simplify both of these. Well, I'm sure that you could tell right away that these do not simplify to the same fraction, so they're not proportional. So these triangles are not similar. Okay, the last thing we are asked to do is to apply some of these similar triangle theorems to prove that triangle ADE, that's the small one, so this is A, this is D, this is E, that it's similar to A, B, C. You are told that line DE is parallel to BC, and that is all we need to know. Because if you look at your properties handout, there are a slew of properties that have to do with parallel lines. One of those properties or theorems is that corresponding angles that are cut by a transversal, corresponding angles that are cut by a transversal and situated on parallel lines, they are congruent. So guess what? This angle is congruent to this one because they're corresponding. They both lie in the same position with respect to these two parallel lines. These two angles are also equivalent because why? Because they are corresponding angles. You also know that angle A is equal to itself, so you really know that 3 different angles are all equivalent. But by angle, we know that these two are then similar. So we'll write that entire proof. So number 1, DE is parallel to BD, and that's our given. And then number 2, I'm just going to go with angle A is congruent to angle A because I love the reflexive property. But you could have just used our 2 that are situated on either side of the parallel lines if you would have liked. So reflexive property. And then I don't have to say that this one is equal to that one and this one is equal to that one. I can just say one of them because angle is sufficient. So angle ADE is congruent to angle ABC. Oops, my numbering's a little off here. And that's because corresponding angles are congruent. Okay, these are corresponding angles that are cut by a transversal, and those are the parallel lines, and that's all we have to put there. We have enough then to say that triangle ADE is similar to triangle ABC simply by angle. And we'll pick up the rest in the next video.